Friends, welcome all. In this session, we will continue our analysis on our normal shock wave. So, students, in the previous sessions, we have discussed various properties of normal shock, various property changes in case of normal shock. So, students, upstream Mach number, downstream Mach number. So that means a Mach number after the normal shock. In terms of upstream Mach number can be written as 2 by gamma minus 1 plus m1 square by 2 gamma by gamma minus 1 m1 square minus 1. So students, this is the relationship between upstream Mach number and downstream Mach number. So we have derived this equation, and I have already told you that there is no need of by hearting this equation, because this equation is readily available in your data book. Okay, now after this we have derived a relationship for a density ratio rho 2 by rho 1 will be equal to v1 by v2, right? Because rho v, product of rho and v is constant, so this will be equal to some gamma plus 1 m1 square by gamma minus 1 m1 square plus 2. So all these ratios are functions of gamma and upstream Mach number. If you know the gamma and upstream Mach number, you will get the values for these ratios. Okay, then we have written the equation for pressure ratio. P2 by P1 is equal to 2 gamma by gamma plus 1 m1 square minus gamma minus 1 by gamma plus 1, right? And also temperature ratio. This is pressure ratio, and temperature ratio is like T2 by T1. T2 by T1 is equal to 1 plus gamma minus 1 by 2 Mach 1 square into 2 gamma by gamma minus 1 Mach 1 square minus 1 whole divided by gamma plus 1 whole square by 2 gamma minus 1 into m1 square. Okay. So two more ratios are there. Stagnation pressure ratio means P02 by P01. P02 by P01 is equal to some gamma plus 1 by 2 m1 square by 1 plus gamma minus 1 by 2 m1 square whole raised to gamma by gamma minus 1 into 2 gamma by gamma plus 1 m1 square minus gamma minus 1 by gamma minus 1 by gamma plus 1 whole raised to 1 by gamma minus 1. So this is a ratio between stagnation pressure in the downstream, for the downstream section, and the upstream section. And finally, I have given you an assignment to find the stagnation pressure of the downstream to the upstream static pressure. So P02 to P1 was asked to write an assignment. So the final answer will be gamma plus 1 by 2 m1 square gamma by gamma minus 1 into same 2 gamma by gamma plus 1 m1 square minus gamma minus 1 by gamma plus 1 1 by gamma minus 1. Sorry, 1 by 1 minus gamma. Okay, 1 minus gamma. So here also one mistake is that this is 1 minus gamma. Okay, this is 1 minus gamma. So students, what is there is an importance for this particular equation. Okay, have you heard about pitot tube? Pitot tube, say pressure. Pitot tube is a pressure measuring device, right? So pitot tube can be used. This equation can be used to used in pitot tube measurements of supersonic flow. So when pitot tube is used in supersonic flow, this equation has got its importance. So what is pitot tube? So what is happening in a pitot tube? Pitot tube will be like this particular, like if there is a flow, okay. This pitot tube is an L-shaped tube. This will be placed here, okay. And when the uh, flow reaches the mouth of that pitot tube, what happens? The fluid is assumed to decelerate. Fluid is assumed to decelerate isentropically. Isentropically to the zero velocity. Zero velocity or to rest means here the velocity is assumed to be here velocity is assumed to be 0. So decelerate isentropically to zero velocity means what will be that corresponding pressure? It will be stagnation pressure, right? Because stagnation pressure is a concept based on isentropical deceleration to zero velocity, right? So that particular pressure that will be shown in that pitot tube will be what? The P0, right? P0 or stagnation pressure. Suppose if this velocity here, suppose upstream velocity pressure is static pressure is P1 and V1 is less than A1 means this is subsonic flow. Okay, subsonic flow. Suppose I'm drawing another case where V1 is greater than A1, that is supersonic flow. Supersonic flow. So here, if the pitot tube is placed here, suppose the flow, the velocity, the static pressure is P1. Suppose since this flow is supersonic, the introduction of pitot tube produces a curved shock, right? A shock will be formed. Why? Because whenever there is a supersonic flow, and when this flow reaches the mouth of this pitot tube means it is getting isentropically decelerated, right? Decelerated means its pressure is getting, the pressure here will be, the pressure in this section will be low because pressure, the pressure will get increased, right? Because the flow is getting compressed. So, suddenly the flow is getting compressed means there is a steep rise in pressure will be increased steeply. So since this is happening in a supersonic flow, when there is a steep rise in pressure means a shock wave, a curved shock wave or normal shock wave forms. Normal shock wave forms means what will be the pressure here then? Since it is isentropically decelerated means it will be stagnation pressure, and that particular pressure will be P02. P02 means the downstream of the normal shock, corresponding stagnation pressure is P02. So the introduction of pitot tube produces a curved shock a little distance upstream to its mouth, right? So the radius of the curvature of this shock wave is large in the region directly in front of the mouth of that pitot tube, right? So after crossing the shock, the stream of compressible fluid decelerates isentropically to what pressure? To stagnation pressure, because it is termed as P02. Why? Because it is after the shock wave. It is at downstream of shock wave. So downstream of shock wave, stagnation pressure is P02. If it was an upstream of that shock wave, it would have been P01. So this value is P02. Therefore, the measurement obtained from the pitot tube. So what will be the measurement showed by this pitot tube? Measurement showed by pitot tube. Measurement showed by pitot tube will be what? Pressure will be at mouth, it is P02, right? So stagnation pressure is directly obtained using the pitot tube. if a wall static pressure probe is used upstream of the shock wave, so if you use a static pressure probe upstream of the shock, you could measure P1, and using pitot tube you can measure P02. So students, you know this equation. If P02 is known and P01 is known, and the gamma or the specific heat ratio of the particular fluid is also known, what will you obtain? You can obtain the value of upstream Mach number. Upstream Mach number, right? Right. So this equation gives the ratio of stagnation pressure at the back of the shock to the free stream static pressure P1, right? P022 by P1. And this can be used for calculating the Mach number at that flow Mach number at that location. So that is why this particular equation is known as Rayleigh-Pitot tube equation. Rayleigh-Pitot tube equation. Okay, so it is used to find flow Mach number. Okay, so that's it. Now we will learn the importance of or we will learn the change in entropy across a normal shock. Change in entropy across normal shock. Change in entropy across normal shock. So what is change in entropy? S2 minus S1. So S2 is the entropy downstream of the normal shock. S1 is the entropy upstream of the normal shock. And it was normally entropy equation is what? Cp log T2 by T1 minus R log P2 by P1, right? Right. So this is the normal equation for S2 minus S1. And since students, even though so S2 minus S1 can also be written as S02 minus S01, right? Okay, because S02 is the stagnation entropy at downstream, and S01 is stagnation entropy upstream. So how these two values are equal? So how can you write S2 minus S1 is S02 minus S01 itself? So you have to look at HS diagram. Suppose this is a normal shock from 1 to 2. So this is a conversion process, right? So 1 to 2. Suppose this is 1 S1 and this is S2 means. So how can you write? How can you find the value of stagnation entropy? Suppose this is H01 or H02 is equal to H0. So corresponding the stagnation and entropy value will be same. So this will be S01 itself. This will be S02 itself. Therefore, S1 minus S2 will be S2 minus S1 will be S02 minus S1. So this is the isentropic process to find the stagnation values. Stagnation values will be corresponding to these 2 points, right? These 2 points. So this point is same of S1, same as that of S1. This point is also same as that of S2. So the difference in static value S2 minus S1 will be same as that of S02 minus S01. Okay. So now just have a look at S02 minus S01. So S02 minus S01 is can be written as Cp log T02 by T01 minus R log P02 by P01. Right? So students, Cp can be written as I think can substitute R as Cp into gamma minus 1 by gamma, right? Cp R equal to Cp into gamma minus 1 by gamma. There is a relation, a Mayer's relation, and you can use Cp minus Cv equal to R, and Cp by Cv is gamma. So using that equation, you will get this equation. So substituting, you will get S02 minus S01 as Cp log T02 by T01 minus Cp gamma minus 1 by gamma P02 by P01, right? So since log minus, actually this is log, right? Log P02 minus P0. So log T02, you can take Cp constant, and log T02 by T01 divided by P02 by P01 all raised to gamma minus 1 by gamma, because log A minus log B is log A by B, or log A minus C log B means log A by B raised to C. You know these properties. I have just applied those properties, okay? Now S02 minus S01 can be written as what? Okay, this is the equation. Cp log T02 by T01 by P02 by P01 raised to gamma minus 1 by gamma. Since the process of our shock wave is adiabatic process, right? So process is adiabatic. For a perfect gas, stagnation temperature remains constant. Stagnation temperature remains constant. So we have already studied those properties, right? We have written H0 equal H01 is equal to H02 is equal to H0, right? Right. So using that equation, you may be able to write from this H0 is Cp T01, right? H02 is Cp T02. So you can write T01 is equal to T02 equal to T0, right? So substituting this here, it will become log 1, right? Log 1, natural log ln1 will be what will happen to that? So the equation will become S2 minus S1 equal to S02 minus S01 equal to Cp log P0. It will be minus, the first value will become 1, right? So it will become 1 divided by P02 by P01 raised to gamma minus 1 by gamma, right? Or you could write Cp log P01 by P02 gamma minus 1 by gamma, or you can take gamma minus 1 by gamma outside, so it will become S2 minus S1 equal to Cp gamma minus 1 by gamma log P01 by P02, and this is nothing but R itself, R log P01 by P02, right? So students, or you can write S2 minus S1 by R equal to log P01 by P02. This is the equation for entropy change across a normal shock. So very important, you already have the value for the expression or ratio of stagnation pressures. You remember I have already written in the initial slides. So this is P02 by P01. So P01 by P02 will be this whole value raised to minus 1, right? This whole value raised to minus 1. So I will be substituting those values here. Substituting our that value in this particular equation, it will become S2 minus S1 by R will be log of that particular value. What was that? Gamma plus 1 by 2 m1 square by 1 plus gamma minus 1 by 2 m1 square. Okay, gamma by gamma minus 1 into 2 gamma by gamma plus 1 m1 square minus gamma minus 1 by gamma plus 1 all raised to 1 by 1 minus gamma. Okay, all raised to inverse, right? Minus 1. So this minus 1 can be taken outside of the log. So what will happen? So you put a minus here. Okay. Now you can simplify this equation. So you could take this, you could split this. So then this is in a form minus log a b, right? Minus log a b is minus of log a plus log b, right? So you could simplify this equation using minus. I am taking that exponent also. So I am taking these exponents also outside. So you could write like gamma by gamma minus 1. Okay. Log, and you could split that particular equation like, or you could divide the numerator. We keep it like this. Okay, no problem. m1 square by 1 plus gamma minus 1 by 2 m1 square, right? Plus, sorry, 1 minus is common, right? So minus 1 by 1 minus gamma log 2 gamma by gamma plus 1 m1 square plus, sorry, minus gamma minus 1 by gamma plus 1. So this is the equation, and you could simplify this equation to gamma by gamma minus 1 delta s by r, right? Delta s by r equal to gamma by gamma minus 1 log 2 by gamma plus 1 m1 square plus gamma minus 1 by gamma plus 1. Okay. Plus 1 by gamma minus 1 log 2 gamma by gamma plus 1 m1 square minus gamma minus 1 by gamma plus 1. So this is simplified form. What I have done is I have I have brought this equation to so that numerator to denominator by dividing this equation, both this term both in numerator and denominator, and introducing this minus inside the log. So it changed like this. You just try it on your own. Okay. So this is the entropy increase across a normal shock, and it is a function of what? Gamma and upstream Mach number. Gamma and upstream Mach number. This is m1 square, right? This is m1 square. So you could get the relationship for delta s by r as a function of gamma and upstream Mach number. So any kind of ratio can be written in terms of gamma and upstream Mach number. So what is this? This is the change in entropy, or actually change in entropy means increase in entropy. In an adiabatic process, since the process is adiabatic, in any case entropy always increase for the system. So okay, so since the flow process across the shock wave is adiabatic, entropy can never decrease. Entropy can never cannot decrease in can never decrease in an adiabatic process, right? You have studied that in thermodynamics in an adiabatic process. So what does that mean? It means delta S by R will always be positive, because delta S its entropy always increases. So students, analysis of this equation indicates that for gases having gamma, the usual gamma values like value between 1 and 1.67. So gamma will be having a value between 1 and 1.67, in between 1.67, right? And for that particular gamma, the entropy delta S by R is positive only when, according to that equation, only when m1 is greater than unity. The students, this particular equation, for values of gamma between 1 and 1.67, this value is only positive when m1 is greater than 1. Okay. So if you analyze that equation, you can find, if you substitute values for that equation, if you substitute value for gamma and a value of Mach number greater than 1, you will get S2 minus S1 by R as a positive value. But when m1 is equal to 1, delta S times will be equal to 0. You can get from that equation, if you substitute a value of Mach number at upstream as 1, you will get delta S is 0. When m1 is less than 1, you will get delta S as less than 0. But this is impossible Why? Because this is a violation of second law of TD. Second law of thermodynamics is violated. Second law of thermodynamics is violated means an adiabatic process can never have a change in entropy less than 0. If a change in entropy is less than 0 for a adiabatic process, it means it is a violation of second law of TD. So this process is not possible means a flow having a Mach number less than 1 means a subsonic flow can never have shock. So a shock wave can never have a shock wave. A normal shock wave can never happen. A normal shock wave can never happen in a subsonic flow. It always happens in supersonic flow. That is the importance. So if you are asked in exam to explain why a normal shock is not taking place in a subsonic flow, you have to explain it based on this particular equation. That is the equation for change in entropy, and according to the equation of change in entropy, you can get the value of change in entropy according to the value you substitute in this equation for gamma and Mach number. When Mach number is greater than 1, you will get delta S by R as positive. When Mach number is equal to 1, you will get delta S by R as 0. When Mach number is less than 1, you will get delta S by R as less than 0. So this is not possible. Delta S by R can never be less than 0 in an adiabatic process. If it is less than 0 means it is a violation, direct violation of second law of thermodynamics. Therefore, a shock wave can never occur in a subsonic flow. That is proved. Okay. Okay. So next we will move to a very important section called Rankine Hugoniot relation. Rankine Hugoniot relations. So we have learned a relation called Prandtl-Meyer relation. That is m1 star into m2 star equal to 1. Right now we will discuss another relation called Rankine Hugoniot relation. Here, here, here actually we are trying to establish a relationship between the ratios of temperature ratio. Sorry, the temperature ratio to to pressure ratio or their density ratios. So these ratios should be related to each other based on this Rankine Hugoniot equation. So this aim of these relations are getting a relationship between temperature ratios across the shock and pressure ratios across the shock. That means static pressure ratios across the shock and density ratios across the shock. So we have already obtained the relationship for these temperature ratios in terms and pressure ratios and density ratios in terms of gamma and Mach number. Now we are aiming to get a relationship between each other in terms of the other. Suppose T2 by T1 in terms of P2 by P1 or P2 by P1 in terms of rho 2 by rho 1 without without having a term of Mach number in that equation. So we have to avoid Mach number, the value, the term Mach number from that equation. Gamma will be there, but we are avoiding Mach number. So students, we have the equation of P2 by P1 as based on Mach number 2 gamma by gamma plus 1 gamma plus 1 gamma plus 1 Mach 1 square minus gamma minus 1 by gamma plus 1, right? So from this equation you can write m1 square as you will get it as gamma plus 1 by 2 gamma of P2 by P1, right? P2 by P1 plus plus gamma minus 1 by gamma plus 1, right? I have move this term to left hand side and multiply and move this term to left hand side. So this equation for Mach 1 square is obtained like this. Similarly, the temperature ratio you have already derived like 1 plus gamma minus 1 by 2 Mach 1 square into 2 gamma by gamma minus 1 Mach 1 square minus 1 divided by gamma plus 1 whole square by 2 gamma minus 1 Mach 1 square, right? And students, what we can do is to get the temperature ratio in terms of pressure ratio. M1 in this equation for temperature ratio is to be replaced by this particular equation. So M1 square here should be replaced. How to replace? To simplify the substitution, initially the numerator and denominator of the equation is divided by m1 square. So before that, I am simplifying this equation by dividing m1 square in both the numerator and denominator. Now the equation will change like t2 by t1 is equal to 1 by m square plus gamma minus 1 by 2, right, into 2 gamma by gamma minus 1 m1 square will be here because there is product, right? So divided by, it will become gamma plus 1 whole square by 2 gamma minus 1, right? So if you take this to numerator, if you take it to numerator, it will become into, again this numerator, it will become into 2 gamma minus 1 by gamma plus 1 square. Okay, so there is two terms having m1 square. So substituting t2 by t1, substituting for m1 square using this particular equation. So substituting using this equation, you will get it will be a very long equation. Gamma plus 1 by 2 gamma p2 by p1 plus gamma minus 1 by gamma plus 1 whole raised to minus 1, because that is 1 by m square, right? So you will get whole raised to minus 1 plus gamma minus 1 by 2. Okay, so first term is done. Second term will be like 2 gamma by gamma minus 1 into m1 square. M1 square is gamma plus 1 by 2 gamma p2 by p1 plus gamma minus 1 by gamma plus 1. Okay, so in minus 1 into 2 gamma minus 1 by gamma plus 1 whole square. So what substitution we have done? We have substituted this particular value and this particular value for m1 square. So here m1 square and m1 square, I have substituted like m1 square in terms of pressure ratio here. So that is what I have done here, and I think now you should do some simplification, and finally simplification, there's a lot of simplification to be done. So I think I should explain all those simplifications, otherwise you won't get those simplification easily. So do one thing, you tightly follow me. Okay, what I have done is here you can see that a 2 gamma is here and 2 gamma is there. This cancels. Okay, and rest remains same. Okay, so this will become gamma plus 1 by gamma minus 1. So gamma plus 1 by gamma minus 1 is here, and gamma minus 1 by gamma plus 1 is there. So multiplying, taking this term inside the bracket means you will get a value of 1, because gamma plus 1 by gamma minus 1 into gamma minus 1 by gamma plus 1 is 1, right? So I am writing this here. So first term remains same, gamma plus 1 by 2 gamma p2 by p1 plus gamma minus 1 by gamma plus 1 whole raised to minus 1 plus gamma minus 1 by 2. So this value remains same, and what changes is gamma plus 1 by gamma minus 1 into p2 by p1, taking inside the bracket, and 1 and plus 1 will be formed, and already minus 1 is there, okay, and this term is okay. Now substituting, okay, and one more term remains, 2 gamma minus 1 by gamma plus 1 whole square is there, right? And now this 1 minus 1 cancels. Okay, and now you do one thing. So this term into this term, so here you can see in denominator you can see gamma plus 1 whole square, and here in numerator gamma plus 1 is there. So this and this cancel, and one gamma minus 1 and gamma minus 1 cancel. So what remains is gamma plus 1 by 2 gamma p2 by p1 plus gamma minus 1 by gamma plus 1, okay, all raised to minus 1 plus gamma minus 1 by 2 into 2 by gamma plus 1 p2 by p1 remains. Okay. Now you do one thing. Now since this exponent minus 1 is common for both these terms, both the terms inside this bracket, you just bring that minus 1 to this term only. So introduce minus 1, this minus 1 to this term only. Sorry, both these terms separately. Then what will happen? This raised to minus 1, this raised to minus 1. So this goes. And what remains is, so inverse of this you have to take. So it will become like 2 gamma by gamma minus gamma plus 1 into P2 by P1 into P2 by P1 plus gamma minus 1 by gamma plus 1 whole raised to minus 1 is still there, plus gamma minus 1 by 2 into 2 by gamma plus 1 P2 by P1. Okay. Now what should be done? Now you multiply this 2 gamma plus 1 by P2 by P1 inside this bracket. So it will become 4 gamma by gamma plus 1 whole square P2 by P1 into P2 by P1 plus gamma minus 1 by gamma plus 1 whole square, and the second term will become gamma minus 1 by gamma plus 1 P2 by P1. Okay, actually this is not square, this is raised to minus 1. Okay, so the equation has now changed like this. And now you have to do one thing. That's a very important step. You just multiply a numerator and denominator by P2 multiply numerator and denominator by what? P2 by P1 plus gamma minus 1 by gamma plus 1. Okay, P2 by P1. So you multiply denominator and numerator by this particular term. So you can even simplify it more. So the equation will become T2 by T1 is equal to 4 gamma by gamma plus 1 whole square into P2 by P1 is already there, and that this term goes because we are multiplying with this particular term. So since this is raised to minus 1, it gets cancelled, and the other term gets that minus 1 by gamma plus 1 P2 by P1 into that, because we are multiplying with this, right? So that term comes P2 by P1 plus gamma minus 1 by gamma plus 1. And that term again comes in the denominator, P2 by P1 plus gamma minus 1 by gamma plus 1. Right? Now you take P2 by P1 outside the bracket. Try to take that P2 by P1 outside the bracket and expand this bracket also. So it will become T2 by T1 as P2 by P1 4 gamma by gamma plus 1 whole square plus gamma minus 1 by gamma plus 1 into P2 by P1 plus gamma minus 1 by gamma plus 1 whole square by P2 by P1 plus gamma minus 1 by gamma plus 1. So students, there is no whole square here. So students, you just open this bracket. If you open this bracket means you will get, just open this bracket. So after opening this bracket, it will become like gamma minus 1 by gamma into P2 by P1, okay, plus gamma minus 1 by gamma plus 1 whole square. Whole square will be there, right? Now, by adding the first and last term inside the bracket of this equation, so adding this equation and this equation, add this term and this term, what will happen? What will happen? So gamma minus 1 whole square, right? So if you add gamma, so note this term. I will tell you. If you add 4 gamma, so students, the denominator is same, gamma plus 1 square and gamma plus 1 whole square. Numerator is 4 gamma is there, here gamma minus 1 whole square is there. So gamma minus 1 whole square plus 4 gamma is gamma square minus 2 gamma plus 1 plus 4 gamma. It is gamma square plus 2 gamma plus 1. So this will be equal to gamma plus 1 whole square, right? So if you add these numerators, you will get gamma plus 1 whole square. So in the numerator also it is gamma, denominator is also gamma plus 1 whole square itself. So that term will become 1, right? So T2 by T1 will become P2 by P1 into gamma minus 1 whole square plus 4 gamma by gamma plus 1 whole square plus gamma minus 1 by gamma plus 1 into P2 by P1 by P2 by P1 plus gamma minus 1 by gamma plus 1. Students, this value will become 1. So T2 by T1 is equal to P2 by P1 into 1 plus gamma minus 1 by gamma minus 1 by gamma plus 1 P2 by P1, right, divided by P2 by P1 plus gamma minus 1 by gamma plus 1, okay. So this is the equation relating T2. So T2 by T1 is related to P2 by P1. So T2 by T1 is written in terms of P2 by P1 and gamma. So this is finally is a function T2 by T1 as a function of gamma and P2 by P1. So this is one of Rankine Hugoniot relation. So this is one of Rankine Hugoniot relation. So this relation between temperature ratio and pressure ratio for an adiabatic shock compression process. Also you can write you can write as rho 2 by rho 1 as sorry, for a perfect gas you can write rho as P by RT, right? P by RT. So rho 2 equal to P2 by RT2 and rho 1 divided by rho 1 as P1 by RT1. So rho 2 by rho 1 can be written as P2 by P1 into T1 by T2, right? T1 by T2. So rho 2 by rho 1 can be written as P2 by P1 into T1 by T2, right? So T1 by T2, you have already the equation for T2 by T1. So T1 by T2 is just the inverse. We just take the inverse, right? So it will be P2 by P1 into P2 by P1 plus gamma minus 1 by gamma plus 1 by P2 by P1 1 plus gamma minus 1 by gamma plus 1 P2 by P1. Okay, this is the equation for rho 2 by rho 1. So this P2 by P1 and this P2 by P1 cancel. So rho 2 by rho 1 becomes P2 by P2 by P1 plus gamma minus 1 by gamma plus 1 by 1 plus gamma minus 1 by gamma plus 1 P2 by P1. This is the equation for rho 2 by rho 1. Okay. So now we have obtained all the relationship. So this is rho 2 by rho 1 in terms of as a function of P2 by P1 and gamma. So these are the relationship between pressure ratio, temperature ratio and density ratio. Pressure ratio, temperature ratio and density ratio. So students, one more concept you have to learn before that, before winding up this particular session. You just learn this term also. Strength of a shock wave. A shock wave is measured, the strength of a shock wave is measured usually in terms of upstream Mach number. If upstream Mach number is very large, means it will be very supersonic in nature, and the kind of shock wave that may occur will be having higher strength. So another parameter to measure the strength of shock wave is beta. Beta is termed as increase in static pressure, the rise in static pressure, ratios rise in static pressure across the shock to the upstream pressure P1. So P2 minus P1 by P1 is strength of shock wave beta. So this can be written as P2 by P1 minus 1. Right? So students, P2 by P1 is already found out, right? So beta can be written as P2 by P1 is 2 gamma by gamma plus 1 m1 square minus gamma minus 1 by gamma plus 1. So this is the value, this is the equation for P2 minus P1 minus 1. Okay, so you do one thing, you just try to uh, simplify this. 2 gamma m1 square minus so denominator is common, gamma plus 1, so this will be minus gamma plus 1 minus 1, right? So it will become 2 gamma plus 1 into okay m1 square minus 2 gamma m1 square minus gamma plus 1 1 minus 1 is there, minus 1 minus gamma, so whole divided by gamma plus 1. You do one thing, because I have taken this gamma 1 plus 2 here, so it will become like this. So opening the bracket, you will get this gamma gets cancels, and 2 gamma m1 square plus 2 divided by gamma plus 1. Sorry, it will be minus 2, okay, it will be minus 2. So you take 2 gamma as beta can be written as 2 gamma as common by gamma plus 1 into m1 square minus 1. So this is the equation for strength of a shock wave. If beta very less than 1 means it is a weak wave. Okay, a weak shock is one for which the shock strength and pressure increase is very small. So if beta is very less than 1 means it is a weak wave. If beta is very greater than 1 means it is a strong wave. So a strong wave has got a very high value of beta. Beta greater than 1, strong wave. Okay. So students, I think I should wind up this session. It has been a bit long. So kindly bear with me, because we have to complete many topics, and your second series is approaching, so we have to complete too much portions. So Kindly excuse me. Thank you.